given the magnitudes of the forces and the angles that the forces act on one another, we can calculate the resultant force using x and y components. So we'll make x and y side lengths on these to make triangles. We can see that the force on the left side is completely in the x direction. There's no y component, so x equals positive 15. Positive because it's going to the right. We can define the positive direction as up and to the right, just like what we're used to on a Cartesian plane. So that makes it easy. And then using trig, we can determine the x and y components of the other two triangles. We can see that the angles would be equal because it's half of 120. They're splitting 120 equally. And remember, to find the side length, let's do the two side lengths of the top triangle in yellow and the two side lengths of the bottom triangle in blue. We use sine for the opposite side length and cos for the adjacent. Remember, sine theta equals opposite over hypotenuse, and cos theta equals adjacent over hypotenuse. We also have to take a look at the direction of the vector. So the 5 Newton forces down and to the left. So the y value will be down and the x value will be to the left. This means y is negative. And using trig, we can see that this would be 5 sine 60. Sine because it's the opposite side length from 60. And the x value is to the left. The x component is to the left, so x is negative to the left. Negative 5, the hypotenuse, times the cos of 60. It's cos because cos is adjacent, and this x is adjacent to the angle 60. Doing the same thing for the bottom triangle, we have our components going up and to the left. So the opposite uses sine again, and it's going up, so it's positive, and this is in the y direction. So y equals positive 10, the hypotenuse 10, sine of 60, because this y component is opposite of the 60, and the x value component is going to the left, so that's negative times 10, the hypotenuse. We use the cos because it's adjacent. And here we can get all of our x and y components of the different forces, and we can add them all up in the x direction and add them all up in the y direction. So we have negative 4.33 newtons, negative 2.5 newtons, negative 5 newtons, and 8.66 newtons. So we'll take the sum of the forces in the x direction and the sum in the y direction, and we'll get our net. So in the x we have plus 15, negative 2.5, so minus, and then we have negative 5. There's only 2 components in the y direction, negative 4.33 and the positive 8.66. And what do we get when we add these up? 7.5 newtons in the x direction. And in the y direction, we get 4.33. So if we want to find the resultant, we can now draw our positive x is 7.5, so that would be to the right. Our y is also positive, so that would be up. So we defined up and to the right as positive. These are x and our y components. And we can find our resultant now. The resultant is found using Pythagorean theorem. So r equals the square root of the squares of the two side lengths, 7.5 squared plus 4.33 squared. And when we do that, we should get 8.66 newtons. So we've calculated this as 8.66 newtons. So that's cool. We can find the angle. So because we were given angles to start with, we should provide an angle with this force. Forces are vector quantities, which are magnitudes with a direction. So we need to give it a direction or an angle. So we could solve for this angle theta using which trig ratio? Tan. We can see we have the opposite and the adjacent from that angle theta. 4.33. This gives us 30 degrees, approximately. And so that's the direction on our vector. So our 30-degree triangle will be somewhere like here.